So for this first example, we're being asked to identify which sampling technique is being used. So it says to determine how many California college baseball players use steroids, the NCAA randomly selects 50 colleges. Every member of the selected college's baseball players is tested for steroids. So in this example, the key really is the word every member. So the random aspect of it is the teams are being selected randomly. But once they have those teams, every single member is being tested, and that is the way a cluster sample works. B. A school official divides the student population into 4 classes: freshman, sophomore, junior, and senior. The official takes a simple random sample from each class and asks the members' opinions regarding student services. So the population was previously divided into non-overlapping groups. This is the main feature of a stratified sample. C. Anderson Cooper asks his viewers to email in their opinion of the president. So there's really no random aspect to this, so we would call this a convenient sample. It's easily obtained, right, and it's not based on randomness. So it's not going to be an effective or representative sample. D. A guest lecturer stands outside the auditorium before the lecture begins and has every 5th person who arrives, beginning with the 3rd person, a speaker evaluation survey to be completed and returned at the end of the program. So the key here is the word 5th. Every 5th person. So this is indicative of a systematic sample. E. 24-Hour Fitness randomly selects 40 club members from their master list using a random number generator and asks them about their level of satisfaction with the club. So this has been done just kind of completely randomly, so this would be considered a simple random sample. If I have a population of 156 people and wish to get a sample of 20 people using the systematic sampling method, what should my K be? So you always take your population size and you divide it by your desired sample size. So let's go ahead and do that in the calculator. So 156 divided by 20. And then whatever number you get, you just cut off the decimal. You don't round it, you literally just cut off the decimal. So the K would be 7. You don't want to round that up because if you round it up to 8, you're not going to get 20 people in your sample. So you really just take the whole number apart and disregard the decimal. So for this example, we're going to determine the type of bias and suggest a remedy. Orange County wants to conduct a study regarding the income level of households within the county. A researcher selects 10 random homes in Newport Beach and sends an interviewer to the homes to determine household income. Okay, so what's happening here is that a certain city is being favored over all other cities in the county. So we're going to call that sampling bias. So obviously they're not going to get a very accurate idea of income level if they focus on a city like Newport Beach, maybe a more affluent area, well, I guess the main issue is they need to go to more cities. The sample size also is quite small. So I would say they need to go to homes throughout the county. Instead of just focusing on this one city. B. To determine the public's opinion of military spending, a researcher obtains a cluster sample of 15 census tracts and samples all households in the randomly selected tracts. Uniformed Marines go to each house to conduct the survey. Okay, so because they sent someone who's specifically part of the military, we're going to encounter interviewer error here. Not only do they perhaps have a vested interest in the result of the survey, They may also cause the people responding to not give a truthful statement. They may feel bad about, saying they want to cut spending or something like that. So they should probably just send a third-party interviewer, not someone specifically involved in the military. C. Cold Stone is going to open a new store in Fullerton. Before opening the store, Cold Stone wants to know the percentage of households in Fullerton that regularly visit an ice cream shop. The market researcher obtains a list of households in Fullerton and randomly selects 150 of them. He mails a questionnaire to the 150 households and only 4 are returned. Okay, so I'm just guessing, but those 4 that are returned may have different feelings about ice cream than the 146 that didn't. So we will call this one non-response bias. I don't think mail is really an effective way to get people to respond to a survey. They may want to try something else, maybe in-person survey, maybe online or phone. Although those might suffer from the same consequence. In person might be the best bet, especially since they went through the trouble of randomly selecting 150 households. Okay, last one here, Part D. A health teacher wants to research the weight of college students. She obtains the weights for all the students in her 9 a.m. class by looking at their driver's licenses or state IDs. There's a couple issues here. I would first say there is definitely sampling bias. She's just going with her class. But also, I would point out that the weight on your driver's license was self-reported, meaning you gave the weight, and I also gave the weight, and it might not be accurate. So I would say there's also an opportunity for a misrepresented answer. People can lie, of course, when they fill out the driver's license application as far as their weight, height, etc. So a couple of things here. She may want to consider taking a random sample of college students instead of just her class. If they're in a PE class, they may be more health conscious, maybe have a lower weight than the general population. And you probably don't want to go with the driver's license. You could weigh people. That might be a little too personal. You might want to do make an anonymous admission of weight. Some people may be fine telling you it, but others may not. Okay, so I'll just say some sort of maybe anonymous survey would be better. Okay, we have an example here for 1.6. To help assess student learning in Laura's developmental math courses, she implements pre- and post-tests for her developmental math students. A knowledge gain score was obtained by taking the difference of the 2 scores. What type of experimental design is this? So anytime there's a pre- and post-test, that is corresponding to a matched pairs design. A person is literally matched up with himself at a later time. Part B, what is the response variable in this experiment? Okay, so it looks like what's being studied afterward, what they're looking for is this knowledge gained score, which is probably just the difference between the 2 test scores. Part C, what is the treatment? So what's happening between the pre and post tests? Well, they are taking the class. Another example here. Researchers wanted to evaluate whether ginkgo, an over-the-counter herb marketed as enhancing memory, improves memory in elderly adults as measured by objective tests. To do this, they recruited 98 men and 132 women older than 60 years and in good health. Participants were randomly assigned to receive ginkgo, 400 milligrams 3 times per day, or a matching placebo. The measure of memory improvement was determined by a standardized test of learning and memory. After 6 weeks of treatment, the data indicated that ginkgo did not increase performance on standard tests of learning, memory, attention, and concentration. These data suggest that, when taken following the manufacturer's instructions, ginkgo provides no measurable increase in memory or related cognitive function to adults with healthy cognitive function. What type of experimental design is this? Okay, well, first of all, it looks like that the treatments were assigned randomly, so I'll probably say a completely randomized design, but there is some aspect of blindness here, meaning there was a placebo, so the experiment was probably either single or double blind, depending on whether or not the administrator of the treatment knew which treatment was being given to each subject. So I'll list that as well. Single or double blind, we're not sure, but definitely one of those because there was a placebo. The subjects definitely would not know if they were being given the drug or the herb or the placebo. Part B, what is the population being studied? Okay, it looks like we're talking early on about elderly adults, so that would be our population. Okay, part C, what is the response variable? Okay, so what did they measure? They measured the scores on standardized tests of learning and memory. Standardized test of learning and memory score. And one more, what is the factor that is set to predetermined levels? So the factor would be the dosages that they were given. So they were either given the 40 milligrams 3 times per day, 40 milligrams of ginkgo. Did I spell that right? Yes. 3 times per day, or a placebo.